Okay, so today we're going to be looking at the S-Tech pitch servo, which is only on SR22s. SR20s, this does not apply. SR20s only have a roll trim and a pitch trim. SR22s have a roll trim, a pitch trim, and an actual S-Tech pitch servo, which on these models is mounted right in there. So this happens to be a G3 Cirrus SR22 with air conditioning. So this is your air conditioning, I believe this is the condenser. The evaporator's up in the front. I think I got that wrong earlier. But anyway, so what you gotta do is you gotta get down in there, take about 100 screws out to get this panel. And then the connector you're looking for, let's see if I can get down there. It's that little black one there. If I can get my light in there any better. There we go. There's a 9-pin D-sub connector in there. Just make it out. So that's what we got to get to. So it's a little tough. You're probably better off loosening up the screws for the condenser here and shifting that out of the way to be able to get your hand down in there. But what we're going to do is the same thing as the startup voltage. We're looking for less than 2 volts on the motor, which is pins 3 and 4. So I've got my test set here. I've got a little connector that this will plug into, and I can vary the voltage here, bring it up to 2 volts or less than. Hopefully we'll hear the motor start to turn. And yeah, I'll be right back once I'm connected up. Alright, so we're connected now, and I'm going to start to increase the voltage, and you're going to have to listen very carefully. It's a very quiet sound. It's hard to do this on a day when people are moving in and out, but if you listen very carefully, you should hear the motor start to turn just barely. Right about there. I don't know if you can hear that. 1.7 volts or so. So let's try that again. Yeah, right about 1.7. Alright, I'm going to go in the other direction now. It's really hard to hear it. That was around 1.8. My fingers aren't fast enough to stop. But I'll get in there so you can try to hopefully hear what it sounds like. It just sounds like a little bit of motor movement. Can't really see much, but hopefully you can hear it. Right there. You hear that? Hopefully the camera can pick it up. But anyway, so this servo is good. If it wasn't good, if it was reading higher than 2 volts, there is a conditioning procedure. Essentially, you run it at full voltage, 28 volts, for about a minute in one direction, just to try to clean off the contacts inside there, the motor brushes. And then you switch directions, and you run it for a full minute or so at 28 volts the other direction. Try to clean up those contacts, because a lot of times these servos, they kind of just operate very small, minute increments, so they don't get to really exercise themselves a lot. And sometimes that'll bring the startup voltage down enough to be within spec. But if not, you're gonna have to send it out to get a overhauled. And that's that. On the earlier model SR22s, you're not gonna have this big giant air conditioning box here. You'll just have a small round plate. Those ones are much easier to access. This one's a little tough because it's kind of wedged in there. So, all right. Hope this was helpful. Alright, this video is to show you how to test the pitch trim servo on a Cirrus. This is under the rear empennage here, and under the horizontal stabilizer. There we go, on the right hand side of the airplane. So right in here, this is your pitch trim motor, and the cabling is right in there, and there's a connector here. I've already disconnected it, but this is your connector that we're going to be connecting to test it with. So same thing, we're going to test the startup voltage on this. For the pitch trim servo, we're allowed up to 5 volts. So we want to hear that motor start to turn at or less than 5 volts for that to be considered a good servo. So I've got my test set up here. Again, I got a power supply, I got a multimeter, just double check to make sure I've got the same voltage on both. They should be about the same. And then I've got my little test box here that allows me to test both the pitch and the roll servos, and because it's the same motor, same deal, and it just goes to pins 1 and 2 on this connector, and it's just flip-flopping 1 and 2, so to drive it one way or the other. Usually they're around the same. Sometimes there's a slight difference between pitch up, pitch down, but usually it's about the same. So I'm going to go ahead and take this, plug this into the connector here. Alright, so I got my test setup connected up there, and this time we're going to start to turn up the voltage, and hopefully you can hear it. Alright, so that was around 6, but let's see. Try again. Ooh, right on the cusp. It was right at 5 that time. So I'm going to go up a little higher. Sometimes if you drive it at a higher voltage for a little bit. So that's 13 volts right now. Alright, so I'll bring you down here so you can see where we're at. See, that's actually high as well. The roll trim was around 6.5 to 7. This one is right at the cusp, 5.3. Let's try the other direction. .9. Yeah, so actually the roll, or the pitch, also probably ought to be replaced. Okay, well there you go. That is the pitch trim servo test. Alright, this is showing how the roll servo trim test functions. So in the Cirrus there's a roll trim servo that will direct your autopilot to roll left and right. And you gotta make sure that the roll, there it is right there, it's in the left-hand aileron. I'm in the, let's see if I go, there's the main landing gear over there. If you come outboard, it's right in here. I'm not sure the wing station number, but it's in the left-hand aileron. All the Cirruses are like this, both the SR20s and the SR22s. They all have roll trim servos, and there it is. And you got to make sure that the voltage, the startup voltage, is less than 3 volts. So that's what we're testing today. So what we're going to do, we're going to disconnect this connector here, and I have a test set up here with a power supply that I can vary the voltage, and I'm going to measure it on my multimeter here to make sure that it's accurate. You probably won't have one of these. This is a homemade testing apparatus that we have built up here. All it does is it takes the voltage in from the power supply, and I can vary, if I want to, I can measure right here, and I can do, this will work for either the pitch trim servo or the roll trim servo, either one, and I can vary if it goes up or down, left or right. So all you gotta do is plug this into the input on the servo. This does not require shipboard power to do. All you need is a power supply like this. Alright, so what I'm gonna do is I'm going to come up here and disconnect this connector here. Let's see if we can do this with one hand. Okay, and this is just going to take the power supply and drive this motor directly. Alright, and what we're doing is we're going to watch the voltage and we're going to listen. When you hear the motor start to turn, that's when you know the startup is actually working. Alright. So this may be tough to hear on the camera, but I will be listening. So I'm going to take my meter leads and plug them in here. Alright. Let's go to volts. Okay, so now I'm going to slowly increase the voltage and listen. Ooh, that's really bad. so we're about 6.9 volts. Let's try that again. 5.7. I don't know if you can hear that. Here's what it sounds like. I'll put the camera right near it so you can hear it. So that's 5.7. You can just hear it starting to grind away in there. So that's too high. So that servo is going to need to be replaced. And now I'll go in the opposite direction. Sometimes it makes a difference. 7.7 that way. Yeah, so this servo needs to be replaced. 6.3. Like I said, so that number needs to be less than 3 volts. Typically it's around 1.5 for a good servo, so that's way, way high. And that's how it's done.